If you've been working through the unit lesson by lesson, you'll know that last lesson we learned how to add and subtract rational expressions that had the like denominators. And in this lesson, we're going to learn how to do it when we have unlike denominators. So our first step when we're looking at a fraction that does not have a like denominator is to find what that least common denominator would be and write the two rational expressions in an equivalent form. So let's look at number 1 here. We want to multiply our left fraction by 3 over 3 and our right fraction by n over n, and that will give us a common denominator of 9n squared. If you're having trouble figuring out what you should multiply each rational expression by, think about what the missing factor is in each one of these two denominators in order for the two to become the same. So I know I was missing a 3 to make it a 9 in the denominator, and I was missing an n to make it n squared, and then I should have common denominators. So let's multiply to get the equivalent forms, and then we'll add these two rational expressions together. Remember, in the numerator, when you multiply, make sure that you distribute your monomial to both terms. So let's rewrite our rational expression. 3n minus 24 over 9n squared. Carry down our plus sign, and we rewrite our second rational expression. 5n squared plus 2n over 9n squared. Now we check to make sure we have common denominators, and we do. They're the same. So let's go ahead and add our numerator together. Write it in descending order. We get 5n squared plus 5n minus 24 all over my common denominator of 9n squared. Now remember, since this is a fraction, an algebraic fraction, we want to see if we can simplify it. So in order to do that, we would attempt to factor our numerator, since it's a trinomial, and then after factoring it, we would see if we could eliminate or remove any common factors. Now there's no GCF in our trinomial numerator, and I know if I factored it, it would have to become two binomials. So in this case, I'm not going to take the time to check if it can be factored, because I wouldn't be able to remove any common factors anyhow. Let's look at another example or two. This time our denominators are not like denominators, but you'll notice our denominators are binomials. So the first thing you should do, if you have denominators that are binomials or trinomials of some sort, is to factor that binomial or trinomial. In this case, I'll factor x squared minus 16 into x plus 4, x minus 4. And now we can look at our two denominators and determine what we would need to do to one or both of them in order to have equivalent denominators. And so let's look. Our right fraction is missing the factor x plus 4. So if I multiply the right fraction by x plus 4 over x plus 4, I should have the same exact denominator of x plus 4, x minus 4. Now let's rewrite our expression. Our left fraction stays x over x plus 4, x minus 4. We're not doing anything to change this one. And we'll keep it in our factored form in the denominator. Carry down our plus sign. Now let's distribute in the numerator 3x plus 12 over our denominator is again x plus 4, x minus 4. Now we have common denominators, and we can now add our numerators together. So if we add x plus 3x, we get 4x plus 12. And our denominator, again, stays the same, since we're just dealing with common denominators of fractions. Now again, we need to check if this can be simplified. So in order to simplify rational expressions, you always factor it and then remove common factors. So let's factor our numerator. You'll notice that the denominator is already factored. Factor out our GCF of 4 in the numerator, and then rewrite our denominator, and then let's determine if we have any common factors. There are no factors that we can remove, so we circle our final answer. And let's do one more together. This time it'll be a subtraction problem. Y over y plus 2 minus 3 over y plus 4. Again, we need to find what the common denominators would be. Now, before I show you the right way, I want to show you a common mistake people will make. Oftentimes, students will think, I should multiply this fraction by 4 over 4 and this fraction by 2 over 2. Because then I'll get 8, right? But when you distribute the 4 and distribute the 2 in the denominator, you'll notice that you do not get common denominators. Let's show what happens when you do this. You would have gotten 4y plus 8 in this denominator, and in the other denominator, it would have been 2y plus 8. So you still don't have common denominators this way. So make sure that when you're doing these problems, you're multiplying it by the entire factor. So in this case, I need to multiply my left fraction by y plus 4 over y plus 4. And my right fraction, my right rational expression, with y plus 2 over y plus 2. You multiply the entire binomial. Now, let's go ahead and see what happens when I distribute the numerators. We get y squared plus 4y over, and we'll keep this in factored form, y plus 4, y plus 2. And then we subtract that with the other expression, 3y plus 6 over y plus 4, y plus 2. Now we have our common denominators, so we can subtract our numerators. But make sure when you subtract, you're subtracting both the 3y and the 6. So let's combine our like terms. We have y squared in the numerator. I'm sorry, I missed my y up here, so let me make sure I write that in. Then I have 4y minus 3y, so that is a 1y. And then I have this 6 becoming a negative 6, because I'm subtracting both terms. You can think of it as like those two terms are in a parentheses there. So I get minus 6. And all of that goes over my common denominator of y plus 4, y plus 2. Now let's try and factor and simplify. So we rewrite our numerator by factoring that trinomial. It'd be y plus 3 and y minus 2. All of that over y plus 4, y plus 2. And again, we see we don't have any common factors that can be removed. So that's our final answer.